Hello, I am Shreya Lokre,
Hello, myself Vasudha Shivne.
and today we are here to discuss about our IoT project, which is home automation. So let us see what we are going to see in today's presentation. What is IoT? What is embedded system? C and C++ role in embedded system. The problem statement about our project, home automation, its scope, the tools and technologies that we have used, next the code and the output. So first of all, what is IoT? Internet of Things. Then what is thing? Is it an internet? So for exchanging data with computers, devices can also exchange data. Can a chair be called as a thing? Smart chair. Posture is maintained or not. Connect sensors to a chair which gives feedback about your posture. So this is about a chair which will tell us about if our posture is good or not according to the with the help of the sensors. Then what is embedded system? An embedded system is a specialized computing device designed to perform dedicated tasks within a larger system. Unlike general purpose computers, it operates with specific functionality and real time constraints, using optimized hardware and software. Embedded systems are integral to various applications from household appliances like washing machines to critical devices such as medical pacemakers, providing targeted solutions and enhancing overall device performance. Then let us see the role of C and C++ for embedded systems. So C is a foundational programming language. As we know, it is a mother of all languages. It is widely used in embedded systems due to its efficiency and close to hardware capabilities. It offers a balance between low-level access to hardware and high-level programming constructs. This makes C particularly suitable for embedded systems, where resources, constraints, and performance are critical. Key features of C that benefit embedded systems include direct memory access, portability, and performance. Let us see each one by one. Direct memory access. C allows direct manipulation of hardware registers and memory, which is essential for controlling and interfacing with embedded hardware. Now, portability. C code can be easily ported across different microcontrollers and platforms with minimal modifications, making it versatile for various embedded applications. Now, performance. Its compiled nature ensures that C programs are executed quickly, which is crucial for real time systems where timing and performance are critical. Now, let us see about C++. C++ is an advanced version of C. It is built on C by adding object oriented programming features such as classes and inheritance, and polymorphism and abstraction. This enhances modularity and code reuse in embedded systems. C++ is also used in embedded systems but is typically chosen for its advanced features and organizational capabilities. Object-oriented design, one of its features, which is C++ allows for creating complex systems with a clear structure through encapsulation, inheritance, and polymorphism. This can lead to more maintainable and scalable code. Now, standard libraries. C++ offers a rich set of standard libraries and abstractions. Although in embedded system, developers often use a subset of these libraries to avoid overhead. Performance considerations. While C++ features can introduce some overhead compared to C, careful design and optimization can leverage C++ advantage while maintaining high performance. Now we have seen the C and C++ role for embedded system. Now let us see the problem statement for our project. Many existing home automation systems are complex and lack interoperability, making it difficult to integrate and control various smart devices seamlessly. Homeowners also struggle with energy inefficiency and a fragmented user experience. This project aims to develop a user friendly integrated home automation system that connects diverse smart devices, simplifies control through an intuitive interface, and enhances energy efficiency to address these challenges effectively. Now, what is the scope of our project? The project will focus on system design, device integration, user interface, automation, energy management, and security. So, it is about home automation. Now, it involves integrating various smart devices to enhance convenience, efficiency, and control within a home. This project focuses on automating and managing critical home systems to improve everyday living. Key components of our project include temperature control system, garden lights, water tank management, heater, and cooler. Automated regulations of indoor temperature through smart thermostats and climate control units. This system adjusts heating and cooling settings based on the user preference and environmental conditions. Garden lights, our project will help to control to on and off the LED lights. Then in water tank management, it will have an inlet and outlet valve to control the flow of the water. Now the cooler and heater control. So for cooler and heater control, we will have a button to control the cooler's fan using the Blink app. So this is what we have done in the home automations, temperature controls, garden lights, water tank management, and cooler and heater. This is the structure of our project where we have constructed it using Arduino Uno. We have files like CLCD, LDR. We have one Ethernet shield, and there is a temperature system. These all are connected to the Arduino Uno, and then we have a serial tank which will be useful for the water flow management, and then we have a Blink cloud where we will be having all of the buttons to control these all peripherals.
Now let's see which tools and technologies we use to build this project. Then first is Arduino. We used Arduino as the main microcontroller to interface with sensors and actuators. Its versatility and ease of use made it ideal for our project. Then second is PixSimLab. PixSimLab we use to simulate and test our embedded systems, allowing us to ensure the reliability of our design before deploying it in a real world environment. Then next application we use is Blink. Blink provided the IoT platform, enabling us to control and monitor our system remotely through a mobile app, offering a user-friendly interface. Then water filling tank system, in which we it will automatically maintain the water level in the tank. We used different types of sensors to measure the water level and Arduino to control the water pump. The main function is if the water level drops below a certain point, the pump is activated to fill the tank. And once the desired level is reached, the pump will automatically get turned off. Then, second used is cooler and heater control. We implemented a design to control both a cooler and a heater, maintaining a comfortable temperature in the environment. Temperature sensors feed data to Arduino, which then decides whether to turn on the cooler or heater based on the predefined temperature thresholds. This ensures the optimal temperature control with the minimal user intervention. Temperature aerial tank monitoring, then we will see how it will work. For the aerial tank, we designed a temperature monitoring system that tracks the temperature in real time. The system uses temperature sensors and the data is sent to the Arduino. If the temperature crosses a certain limit, the defined system can trigger cooling or heating mechanisms to maintain the desired temperature range. The next is remote monitoring and controlling, how all the access should be given. All the systems are connected to the Blink app, which we have downloaded on our mobile, which will allow remote monitoring and control. Users can check the water level, temperature, and system status directly from their smartphones. Then Blink app also enables us to send the alerts and the notification in the case of any abnormalities, ensuring the system remains functional and efficient at all the times. Then, in conclusion, our project demonstrates the practical application of IoT in automating the household and industrial processes. Looking forward, we plan to expand this system by integrating more sensors and controls, which will enhance the automation and efficiency of our sector.
So, first, these are some code snippets that we have used for the uh, project implementation, such as this is an example of home automation blink controlled blink file. Then we have this serial tank file. Such as these files, we have many other files for like LDR, CLCD, which will be this code will be helpful to control our devices. Now, let us see the Blink app working.
Interface. Then in our project, we use the Blink app as the central hub for controlling and monitoring all the aspects of the system, which include cooler, heater, and temperature regulation. Then buttons for cooler and heater. We added dedicated buttons in the Blink app to manually control the cooler and heater. These buttons allow the users to turn this device on or off with the simple tap, providing the direct control when needed. Then second is the temperature monitoring. The app also features a real-time temperature display, as we can see here, showing the current temperature inside the aerial tank. This data is continuously updated, ensuring the users can monitor conditions at any time. Then another feature is notifications. We have configured the Blink app to send notifications for important events. For example, if the water level drops low or if the temperature exceeds a certain threshold, the app sends an instant alert to the user. This proactive approach helps in maintaining the system efficiency and prevents the potential issues. Then uses of our Blink app. This app offers an user-friendly interface, making it easy for users to interact with the system, whether it's checking the status of our if we are online or offline, or controlling the devices. Everything can be done seamlessly through this app.
With this app, we can create buttons, like she said, to control the devices. There is also a Blink website where we have created the data streams for cooler, heater, temperature system, and notifications. Due to some issues, we cannot include the data stream for notifications, the terminal. But for others, we have included, and these are included in the screenshots shown. Mm, and these are some of the snippets. Now let us see the demo of our project. So these are the code files in C that we have implemented for the home automation project. So this is the home automation blink controlled file where the overall working is there. Then in the temperature system, we have included the working for the heater and cooler both. Then in the LDR file, we have included the code for its working, garden light, for its input and output. Then in CLCD file, uh, yeah, in the CLCD file, it is for the again for temperature and overall thing. Now let us see the Pixim lab. In the Pixim labs, as I have shown the code files before, so first we compile it, then we export its binary file, and then we load its hex file using this button, like here shown in the picture. Here serial tanks bootloader hex file is been loaded. This is the overall Pixim lab. Using this, we reset the uh, chip Arduino. Then we can include the modules and tools and the spare parts, like just a minute. As shown, due to some issues, this is not working. It was working before. So this is the temperature system. This is LDR. This is uh, LDR, which works like when it goes down, the light blinks. Then this is LED. This is fan for heater and cooler both. So this is the overall components. These all our components can be controlled using the Blink app with the button that we have included, were included in the PPT. And we can see the serial tank implementation. So we have to first import the port. So we have COM1 and COM2 we have included. So we selected the COM2, and COM1 is already configured. So now let us see. As you can see in the image, so this is getting the water is getting filled from the inlet, and once it is getting full, when the instructions came, it can be gone with the outlet valve, and upon the as per the instructions, as you can see, it is getting down, it is getting empty. So when it gets empty, it again gets poured in, filled. So this is what it has been coded in the serial tank files. So that's the working of serial tank. So this is what we have learned. First, in the overall journey, it was very wonderful. The ma'am taught us C, then C as advanced C++ features, the concept, then bit manipulation. After that, they taught us, went,
different tools.
they give us a overview of all of the tools. They made us familiar with all of the platforms like Arduino and Pixim Lab, Blink app, and also its website. In the Blink website, we have created the data streams. As you can see, this is what we have created for home automation. Then in home automation, one device is connected, which is VS device. This here we can see its status, whether it is online or offline. We were not able to show the output using the Blink app because it was showing us the offline issue even when we are online. So it was some network issues, like I guess. Then then using this device, we have all of the buttons and the data streams. As you can see here, we have we have created VS device. Um, just a minute. So these are the data streams created. So this website has one constraint of only making us available of 5 data streams, and when we tried to create sixth outlet valve for the data stream, it was asking for a paid subscription. So we created these 5 uh, data streams like cooler pin, temperature, heater pin, notifications, and inlet valve, which were then useful for the mobile app Blink to control the all of the devices. As you can see, for cooler pin, we have given the integer data type. For temperature, as it can be in decimal, so we have created its double data type. Then and units are degrees. Um, then for notifications, we have given the data type as string, and for notifications we have to include the design as a terminal, but also it was again asking for the paid subscription, so we were not able to do that. But then we have implemented, but the LED through Blink app was working. It was working efficiently. When we click on the on button of the app, the LED was turning on the Pixim Lab, as Pixim Lab on the show, in the shown images. This is the Pixim Lab, but here as this the LED was working efficiently when the on button was clicked on the phone. So this is the overall working. The fan was also turning on when the button was on. So in this way, we have created the project efficiently. Everything was working, but due to some issues like the paid subscriptions and the limit of 5 data streams only, we were not able to complete all of the things. And there was also an offline device issue. So Yeah, and using this project, we gained very good insights about the IoT and how we can use how we can make use of IoT in our day-to-day lives and make our lives easier. And we learn to control how we can control the day-to-day devices like lights, fans, using the phones because of the sensors and the devices that can get connected to the internet, and with that they can communicate with each other, they can share the data, and so that we can connect them, and this can make our life easier. So thank you for giving us such great experience, and we are very grateful. Thank you so much.